All right, hey, Maya and Clayton, this is the last example on section 7.2. We are graphing cotangent, okay? I'm going to change this problem. I'm going to change this problem for now to get rid of the minus pi over 2. So just do -3 cotangent of t. That's all we're going to graph, okay? Before we graph -3 cotangent, I don't like cotangent of t. Can I change that to be an x? Because I can't do cotangent and t then right next to each other. So I'm going to change it to x, okay? -3 cotangent of x, that's what we're graphing. Y equals that thing. That's what we're graphing, okay? Before we do that, up at the top, in this margin up here, we're going to graph tangent of x, and we're going to compare just tangent and just cotangent, okay? Because when you're graphing secant, you first graph cosine. When you're graphing cosecant, you first graph sine. When you're graphing cotangent, you don't graph tangent first.
It's just that.
Okay, it's just that way. So here's how tangent looks, right? We have this and we have this, and he goes from, where is his, what?
Pi over 2.
Negative pi over 2 is his left vertical asymptote. His right vertical asymptote is positive pi over 2. And then he kind of looks like a cubic function from there, right? He starts here in the middle and he goes up.
Wait, let me slow down.
And he starts here and he goes down.
You're fine.
Yes, ma'am.
I'm a bit behind. You're fine. Negative. Why do your lips slow down for some? Yeah, for real.
Because she pays attention.
And I don't.
If she pays attention,
Correct.
she wouldn't be
Alright.
What?
What?
You've already
Why
taken
she always
this
gotta be
test.
the one that slows down?
All right. Now, here's the deal. Well, tangent really doesn't have an amplitude, but if we're going to talk about amplitude of tangent, right? If we're going to talk about amplitude of tangent, over here, like right in between 0 and pi over 2, what is this marking right here?
1.
This is pi over 4, and he is located at 1. That's where that coordinate is, right? And this will be at negative pi over 4, and he'll be at -1.
Yeah.
So when we change this to be like a 3 instead, it's going to make him taller and skinnier. Does that make sense? Okay, so that's kind of how that works. All right, now we're going to compare tangent to cotangent.
I bet I just flipped them.
Okay, kind of. All right, let's go over here to this side. We're going to do some comparisons. So first thing that's different. Actually, let's talk about something that's the same. The period for tangent.
It's the same, Z's.
What's the period for tangent?
Negative
No,
pi over
no.
2.
How far apart is he?
Right,
Pi.
tricked
He's
me.
pi, right? He's pi units wide. Cotangent, the period is also pi. Okay? Cotangent's period is also pi, except, and he does have vertical asymptotes, except he doesn't split pi over 2 on either side. He is actually easier. He starts at 0, and if he starts at 0, where's his next vertical asymptote going to be? At pi. So he goes from 0 to pi, which means this place here in the middle, where he's going to cross, is at
Pi over 2.
pi over 2. And he's going to go
The fatter version.
the other way. He is the same. He is exactly the same. He's just shifted over and he's flipped.
Shut up, Marcus.
Okay? All right, so you ready for this?
All about perspective.
See if you can follow along with this. If this is confusing, you can ignore it. But see if you can follow along with this. Ready?
Yes,
Okay?
ma'am.
Cotangent of x is exactly the same. Check this out.
Negative tangent.
Negative tangent of x minus
Pi.
pi over 2. Because we've shifted in pi over 2 units to the right. Correct?
So you're gonna put that on our test and try
Those
to
are
trick
the
us.
bits.
Cotangent of x is the same thing as tangent, shifted pi over 2 units to the right, because I'm taking this and I've shifted it pi over 2 units to the right. So my vertical asymptotes are lining up here instead, and he's flipped backwards. So that's exactly what tangent is, or cotangent is.
We only
Yes?
have 3 days.
Those two things are the same thing, right?
I'm so excited.
Good?
Too many.
Okay, wait.
We're like, hopefully, only going to school 3 days a week and such.
All right, good. Moving on. All right, let's graph this one now.
Who does?
Should we try graphing the minus pi over 4?
No.
No.
He
Really?
got suspended. That's
Maybe later.
Maybe later. We'll do this one first and then we'll graph minus pi over 4. Okay, here we go. All right, so -3 cotangent. That is not moving my vertical asymptotes. So I'm going to still start them at, I'm going to still start my vertical asymptotes at 0 and at pi.
Over what?
0 and pi. Okay, 0 and pi. All right, now this guy right here is at pi over 2. And the 3 The way that I'm going to incorporate the 3 is, what is this marking right here between 0 and
Pi over
5 over 2?
4.
Pi over 4. What is this marking?
That's where 3 is gonna be.
What is that marking?
Oh, pi over
3
6.
pi over 4.
Pi over 6.
Uh-uh.
Pi over
Uh-uh.
1. Pi.
This is a fourth of a pi. This is a
3
half of a
fourths.
pi.
3
This
fourths.
is
3 fourths. I
3/4
said
pi.
that.
What does 3/4 pi look like?
3 pi over 4.
3 pi over 4.
Somebody said that. Somebody
Okay.
literally said
All right,
that.
now he's going 3 tall and 3 short. So 1, 2, 3. Shh. And 1, 2, 3. 3 tall, 3 short. There you go. 3 and 3. Now, he is negative also, which
So
is
it looks
somewhat
like tangent.
confusing
So it
because
ain't tangent.
negative, I think he's going downhill from left to right, right? But cotangent already goes downhill from left to right. So he's actually going uphill, which is weird.
So he's normal.
So
He's normal.
And that's just freaking
down here, he's
weird.
going to be there, right? And then he's going to be here, and then he's going to be up here, and then he's going to do like that type of thing, okay? So he goes this direction. Something like that. I can't do that. There you go. That's better.
That's exactly what he did too.
Okay, that's what he looks like. Yeah? All right.
I just heard you say that. I was just like, oh my gosh. That was
You
just
suicidal?
insane.
All right, let's do this really quick. One more thing to graph. Let's graph.
It's not the same freaky.
Let's graph negative cotangent of, get rid of the 3. Let's do negative cotangent of x minus pi over 4. We'll incorporate the pi over 4 shift, okay? So we're going to graph one more over here.
I don't think so.
You should do negative cotangent.
Nah. Negative cotangent of x minus pi over 4.
No,
That's what we're gonna do.
So
said
it's
that it's
tangent. Tangent moves.
No.
So
No.
the
Move
so
to
the
the
first
left.
vertical asymptote is at pi over 4
Yeah.
on the positive
Okay,
side.
so normally it's at 0, but we're going to go pi over 4. This goes to the right. Shh, you guys got to listen. We're going to the right pi over 4. Here is pi over 4, and I'm going to do my vertical asymptote. Okay, now, how wide is cotangent?
Pi.
Pi.
Oh, pi.
So I'm going to put my other one over here. Where is this guy hitting if it's pi later?
2 pi, 2 and a fourth pi. 1 and 4.
1 and a fourth pi. What's 1 and a fourth pi?
5 fourths.
5 fourths.
5 pi over 4,
5. Yep, 5. I knew that. You're
right? If I take pi over 4
shut up.
and I add a pi to it, right? This is like adding 4 pi over 4, right? Which is 5 pi over 4. All right, where's exactly in the middle? Shh, where's exactly in the middle?
Pi. 3
Yeah,
pi
that
over
would
4.
be a movie.
Hey, guys, you're not listening. What's
Yeah,
exactly in
3
between
pi over 2.
pi over 4 and 5 pi over 4? This is 1 pi over 4 and 5 pi over 4. Exactly in the middle is
2.5.
3 pi over 4. 1 pi over 4, 5 pi over 4, 3 pi over 4. 3 pi over 4 is the middle. Okay? That's where he's going to touch. Now he is negative, which means he's going uphill again, right?
On jujitsu.
But this dot right here and this dot right here is only going to 1 and negative 1. So he's not going to be quite so skinny, right? He's going uphill, so he's going to touch here and here and here. So he does this and he does this. Okay? He's not quite as skinny as what that one was, right? Make sense?
What does a, just out of curiosity.
What?
Stop!
What
That's
does
my
a-
physics review.
So that would look like tangent? Like negative cotangent would look like tangent.
Yes.
So if it's negative cotangent, it goes like that.
What is your problem?
Yeah?
Confusion.
Can I be Kashot?
But it's shifted left and
Where
right.
does it usually start? That's not, wait, it's shifted. Well, yeah.
Negative cotangent looks like tangent, except the vertical asymptotes are not in the right spot.
Where are the vertical asymptotes at?
So like normally tangent.
I don't get it.
Normally tangent. Normally tangent goes from here to here, and it goes
Yeah. From negative pi to pi? Or from,
negative pi over 2 to positive pi over 2.
yeah. But where is it on, when you do
Goes
cotangent?
like this and like this, right?
Yeah.
That's what tangent does.
Yeah, what about?
So negative tangent would
No,
just
no,
go from
no.
here to here.
Negative cotangent.
Negative cotangent, okay?
Yeah.
So that's tangent.
Okay.
Cotangent goes from here to here, and it goes
From pi to 2 pi? Or from 0 to pi?
0 to pi. And this is
Zero to pi.
cotangent, right? So negative cotangent would go like this.
So
So he would look like tangent, but not in the right spot.
So the dot would be at pi over 2.
What? Yes, the dot would be at pi over 2, right?
Yeah.
Where normally tangent's vertical asymptote is,
Hold on a minute. Contra.
right?
Yeah.
So he looks like tangent, but he's not in the right spot.
Madam.
Right.
Madam. Will you come
Okay.
get this real quick? Real fast, like?
Craig,
Can you?
I'm gonna take that away from you until you have your homework assignment done.
I was texting Alyssa.
I don't care.
That's your mom.
Because I don't think I did. Because I don't think I did it right, but I think I did it semi-right. Here you go. Oh,
I know.
Okay, so you're 2 down,
yeah, I made a line in
and
it.
this is pi, right?
Sure.
And this is pi over. Let's split them in half.
Marcus,
Split them in half. Let's split them in half.
what do you have on 7, 8, 9, and 10?
So this is pi over 2. Okay. Now,
ACDB.
whatever you're doing.
Is that
this
right?
Pi over 2 should hit right here.
Marcus,
On your line.
is it right?
Right? Yes.
Yes.
Okay.
Yes.
Sure.
See that?
Guys, I'm done with my homework.
And it's one above.
It looks like this. That's what I just asked you.
So this one.
Problems, but it'll be fine. You're gonna be all right. Brr.
Rachel,
What?
get over here.
Why?
You want to finish speaking?
I need to write my physics problem.
That seems like a later problem.
No, it's not, because we have class and I won't have time to.
You are right, but I'm not going to start it right now. I'll start it later. My book's too good.
Where's everyone go?
Joe's. Joe's.
Does he? Doesn't he like hate?
Yeah, what else? She's a freaky.
Yeah. But we just don't care.
You can help me clean. Mallory, you can write my board.
Write it?
Yeah.
Okay. Why are we cleaning? Is it because someone's coming tomorrow?
Yes. Well, no, and I'm not cleaning because, like, I want it to be clean. He has a notoriously, Dr. Schneider, has a notoriously it's terrible, his desk. Like, there's papers everywhere. So, I
Why
don't
you use one of these
care about
as
having
black?
it clean for him. I just want to
Show him up.
to make it known that I am less messy than he is.
Okay,
You know?
where are we? Is this the last
Go look at my book. It's all updated. There you go. So,
It's all updated?
Yeah.
Everyone's up to date?
well, like those are it's Monday, so everybody should be up to date, right?
March 7th. Geometry is special right triangles. I need like a chair. Sarah, come read to me.
I got these all repainted,
Yay!
and I'm painting the other one.